I'd like to welcome you to our podcast where we're going to look a little bit closer at our periodic table. And when we're looking at our periodic table, we know that we have a bunch of boxes and they all have some pieces of information in them. And the example that we have here on the board is the exact same as that you have on the back of your periodic table. There's this box tells us actually some very important information. First of all, it does tell us the element name. It also gives us the element symbol. Now, like carbon here, this is pretty straightforward. Carbon starts with a C, the symbol is C. But for some things like iron, iron is actually Fe. The Greek word for iron is ferrous. So in that case, the elements on the periodic table, their abbreviations are actually because of their Greek or Latin names, not what we necessarily call them. So when you're looking for elements, you're going to have to keep that in mind. It tells us two other pieces of information. We have the atomic number up at the top. This is, so for carbon, your atomic number is 6. And notice that our elements on the periodic table, their atomic numbers increase by 1 as you move through. Now, your atomic number is going to tell you the number of protons. And for most of our, actually all of the elements on the periodic table, they are neutral, which means that the positives equal the negatives. So if the atomic number tells us the number of protons, it has to also tell us the number of electrons. And we're actually going to talk about ions here in a couple of weeks where things are going to have a positive or negative charge. But for right now, everything is neutral. And so our atomic number equals the number of protons, which also then has to equal the number of electrons. Then down at the bottom, we have this 12.011. This is my atomic mass. Just like everything else, atoms have a mass to them. Atoms are weighed in something called the atomic mass unit, or the AMU. The atomic mass is found by taking your neutrons and adding them to your atomic number. So we could also, in this case, for carbon, we could figure out how many neutrons it has. We have our atomic mass, which is 12, and we're trying to find neutrons. And we know that the atomic number is 6. So we know that in carbon, we have 6 neutrons. We are going to have 6 electrons because we know that electrons equal protons, and we know that we are going to have 6 protons because our atomic number was 6. So that's just a couple of pieces of information about what you would find on the periodic table. Now this 12.011, this atomic mass, it brings up an interesting point because carbon doesn't weigh 12.011 atomic mass units. Some carbons weigh 12, some carbons weigh more than 12. So that brings us to isotopes. Isotopes are individual atoms, but they all are going to have a different number of neutrons. But they're the same atom. So it's carbon, right? The atomic number is the same, but the number of neutrons are going to be different. So in this example, I have circles. Let's pretend circle is my element. And I actually have 5 different circles that I have discovered here on Earth. And 3 of the circles that I found weigh 5 atomic mass units, and 2 of the circles weigh 15. But they all have the same number of protons. So they're the same element, but they're just a little bit different. So I'm not going to be able to put an atomic mass of 5 and 15 on the periodic table. So what I would do is I would actually have to find out what the average of this is. So I have 3 of them that weigh 5 atomic mass units, and I have 2 that weigh 15 atomic mass units. So I have a total of 45 atomic mass units, but I actually have 5 atoms that I've got to be able to split this apart by. So I'm going to take 45 divided by 5. So I'm going to have an atomic mass unit of 9. So when I would look at my periodic table, if we just want to draw one really fast, circle is my element here. Oh, I better write circle in there so we don't get confused. If my atomic number is X, I'm actually going to put my atomic mass of 9. Okay, so I have different isotopes. I have circle isotope for 5 AMUs, and I have a circle isotope that weighs 15 AMUs, but when I average them all together on the periodic table, I'm actually going to have an atomic mass of 9. Okay? So let's use carbon as our example. We have an atomic mass of 12.011. We actually see in the environment, we see C12 and C14. Since our atomic mass is closer to 12, this tells us that when we go out in nature and we actually look, we have way more carbon 12 atoms than we have carbon 14 atoms. But because carbon 14 exists, it has 6 protons and 8 neutrons. Okay, so it's just a little bit different than carbon 12. We have a couple of them, but when we average them all together, we get an atomic mass of just over 12. So in this podcast, hopefully you know how to read that your periodic table just a little bit better, and you should be able to tell me about isotopes. And if you know an isotope, you should be able to tell me the number of protons that element has, and why it has a different number of neutrons than the elements that we have on the periodic table.